What's up, guys? This is Michael with Michael Talks Metal, back for another talk on some nickel today, specifically Inconel 600. And so if you guys have been enjoying the videos or enjoying this video, please consider subscribing. Just click that little button right there. Whoop! There it is. Whoop! All right? If not, maybe drop a quick like. Appreciate it. So let's jump in. Today, we're going to be talking about and taking a look at one of the more popular of the nickel alloys. And this is known as Inconel 600 when it is produced by Special Metals Corporation. If it's not produced by them, you got to call it Alloy 600. So if Carpenter does it, it's Alloy 600. They don't own the trade name Inconel as Special Metals does. So the UNS chemical composition designation is N06600. This alloy is a solid solution of its elements and cannot be strengthened by heat treatment. Cold working will result in increased strength. Now, heat treatment can remove any undesirable effects of cold work. Nickel alloys are used in applications involving elevated temperatures, corrosion, or both. Chemical processing equipment relies on corrosion performance over a wide range of environments. Commercial applications involve furnace components and fixtures requiring strength and oxidation resistance at temperatures up to 2,000 degrees Fahrenheit. Pretty hot. Aerospace applications include high temperature components of jet and rocket engines. So, after getting a little viewer feedback from a gentleman named Ramin, sorry Ramin if that's not how I pronounce your name, but I figured it would be useful to display the chemistry as well as rattling off all the numbers which could perhaps sound a little or slightly overwhelming at times. To the chemistry. So, here we are. Just put that right here. Oh, right there. All right, so we got nickel plus cobalt, 72% Min. Chromium, 14.0 to 17.0%. Iron, 6.0% to 10.0%. Carbon is what is carbon? Let's find out. Hey, carbon is 0.15 max. Manganese, 1.0 max. Sulfur is 0.015 max. Silicon is 0.50 max. Copper, lastly, maybe. Is there anyone else hiding in there? I don't think so. Copper, lastly, is 0.50 max. So, there's your chemistry. Typical room temperature mechanical properties in the annealed condition are a yield strength of 30 to 50,000 psi, tensile is 80 to 100,000 psi, and elongation is a 35% to a 55%. Density is 0.306 pounds per cubic inch, and remember, that's about 3 times heavier than steel. Now to an even more fun stuff. So, more specifications, right? Let's try this side, yeah? Okay, so here we go. So here's all the specs. We need lots of room over here. Now, I am going to just tell you the AMS specs for bars, sheet, pipe, and tube, and we're going to go with that. The rest of the stuff, as you can see, is here, right? So, for bars and forgings, we're going to be in AMS 5665 and AMS 5687. The AMS on the sheet and plate is AMS 5540, and lastly, on the pipe and tube is an AMS of 5580. And so again, there you are. There's all the information you need. So, last, not least, each specification has requirements that can add or restrict the chemical composition beyond what we have shown you today. So, we also know that other processing and testing requirements exist in individual specifications. What does that mean? That means that you need to be sure that all requirements have been identified. So, we will remind you again. to check the specs. And so this is Michael with Michael Talks Metal. I appreciate you guys tuning in. Thank you for watching. If you made it this far, haven't subscribed, please consider subscribing. It'd be pretty helpful. And if you missed any of the previous videos, well, there they are. Appreciate it. Thanks for watching. This is Michael with Michael Talks Metal. I will see you guys next Thursday. Appreciate it.